Alright, so section 8.5 day 1 is going to talk about what they call recursive rules. Okay, an explicit rule gives you a function in the terms. A recursive rule means that it's based on the preceding numbers. Okay, so the one thing about recursive is that you got to make sure that you're very accurate in your computations. If not, you're going to throw off the rest of the number sequence. So you got to make sure, because it's based on the previous answer. So the first thing that they're going to have you do is they're going to say write the first 6 terms. Okay, so that's the first thing that they're going to do is have you list the first 6 terms. What they're going to do is they're going to give you a starting point. So something like this, where it's going to say a sub 0 equals 1, and then it gives you the rule of a sub n equals a sub n minus 1 plus 4. Now this part right here means recursive. It means the previous answer, and I'm going to show you how that works when we start inserting numbers. If I try to find a sub 1, which is the first term, if I put 1 in for n, that means in the bottom I get 1 minus 1, and then it's plus 4. Down here only, 1 minus 1 is 0, so that's a sub 0 plus 4. Well, a sub 0 they gave us is 1, and 1 plus 4 is 5. Then to find a sub 2, you're going to put 2 in for n, so 2 minus 1 plus 4. 2 minus 1 is 1 plus 4, so they want the previous answer. When they say A1, they want, well, what did you get the last time? You got a 5. Plus 4 equals 9. Okay, a sub 3. 3 goes in there, plus 4. So you end up with a sub 2 plus 4 equals, okay, so then again, a sub 2, you're just putting the previous answer in there. So 9 plus 4 equals 13, and so on. So I hope what you're seeing is what it means by recursive is I'm just inserting the previous answer in for that spot, and I'm coming up with, in this case, we're just adding 4, okay, or something to that effect for some of the other ones. But that's what it means by recursive. Recursive means you're going to plug in the previous answer and see what you get. Okay, so just so that you know, and then again, they would want you to go up to 6. I've just done the first 3 just to show you a little bit how it's working, but they want you to find the first 6. So you would go out till you have 6 of them in a row. Okay. Another notation for that, or another way that they're going to write that, is they might say something like this, where they say f of 1 is 1, and then the function is 3 times f of n minus 1. Okay, this again is also a recursive rule. It's just in function notation rather than a sequence notation. So for this one again, the next number, now this is where it gets a little bit confusing for some people. When it says the first 6 terms, they already gave you the first one, so you don't have to find it again. It's 1. And a lot of people screw that up because when they say the first 6 terms, that's one of them. Okay, so you don't have to find, when they say the first 6, you only have to really find 5 of them on your own. So when you're finding f of 2, again, remember that means you put 2 into the equation. That's a times sign, by the way. 3 times f of 2 minus 1. Well, 2 minus 1 is 1, so they want you to put the previous answer in there and to find your next term. So if I go f of 3, that says 3 times f of 3 minus 1. Well, 3 minus 1 is 2, so f of 2. So I end up with 3 times 3, or 9. Again, what's happening is I'm putting the previous answer in to get the next number. So just to give you one more here, if I do f of 4, that's 3 times 4 minus 1 equals 3 times f of 3, which again we just found was the number 9, and 3 times 9 is 27. So again, this number just went into the next one. So it's very important that you are very, very careful when you're doing this. Don't get sloppy with your math, because If you do screw up one number, you've just screwed up the rest of them. So that's what it means when they want you to find the first 6 terms of the sequence. Again, recursive means it's based on the previous answer. Okay. Now the next part that they're going to have you do is they're going to have you write in the rule. Okay. When it's an arithmetic one, the rule is it's a sub n equals a sub n minus 1 plus whatever the d is. And from previous lessons that we had before, d meant common difference. Okay? Common difference, again, is just the number which you're adding or subtracting to every time. Okay, so if you recognize that it's adding 10 or adding 5, subtracting 3, those are your d's. When it comes to geometric, it looks like this. A sub n equals r times a sub n minus 1. And again, the r stands for the common ratio. And common ratio, again, is the number that you're either multiplying or dividing. Now, when I say dividing, just to remember, remind you, that's really multiplying by the reciprocal when we say that. We don't ever say divide by 5. We would say multiply by 1/5 in this case. So to give you some examples of these, what you're going to do is you're going to just write the rule. So looking at something like this, okay, so there's the pattern that's been established. So what you have to do is, or what I like to do is, if I use a table to kind of organize the data, and I've done this before, where I've just put 1, 2, 3, 4, 5 on top of those. Those just mean the number of terms. Okay, so the first term is 3, the second term is 13, third term is 23, and so on. So what I need you to do then is look to see, how is it going from here to here? How is it moving from here to here? Is it the same? Is it different? How? So if I look at that pattern, 3 to 13 is adding 10 or multiplying it by some number. Okay? But if I take from 13 to 23, that's also adding 10. So it looks like if I just add 10, I've got my pattern. Now, based on previous sections, when you're adding 10, you are then in arithmetic sequence. So for this particular thing, a sub n equals a sub n minus 1. That part's not going to change. That's where you put the new material or the previous answer in. So you need that in order to be in your equation. You do not need to do anything for that part. Plus, and then we found that it was increasing by 10. Now, the biggest thing that you also have to do with that is you have to tell the reader, hey, here's your starting number. If you don't tell the reader where to start, they're not going to make your pattern. So you need to tell them where to start. If you don't tell them where to start, you're going to get it wrong. Okay, so it's important not only to have the formula, but also to have the starting point. Because if you don't have that, it's wrong. Okay? The next one. If I had something like 16, 40, 100, 250, 625, okay, if I go by the adding feature, again, that looks like if I add 24, that would give me 40, but 24 plus 40 is not 100, so adding is out the door. So if it's not adding, it's probably geometric, okay, meaning it multiplies by the same number. In order to find the ratio, again, remember you would take the second term divided by the first term, or in this case 40 over 16, which reduces down to 5 over 2. Okay, so again, all I did was take the second term divided by the first term, and that gives me the ratio. So according to the formula, a sub n equals the ratio, which you just found was 5/2, times a sub n minus 1. So that's my equation. Now again, if I leave it like that, it's wrong, because what number do I start with? Who knows? If I don't tell you a starting number, I could tell you 80 million, and it would not make the pattern that we have established. So you also need to list the first term. or a term, especially probably the first term if possible, just because then that way it gives the reader where you're going to start, because if you don't know that, you're not right. Okay, so again, when you're looking at writing the rules, let's look at both. Does it add something first or does it multiply? Okay, and if it's adding or multiplying, then we'll write it in either form. Okay, but don't forget that first term, because if you do, you're not right. Now the last part of the stuff is going to be what happens if you have something different. Okay, so if I've got something like this, I'll give you enough to hopefully figure out the pattern or what I'm doing. This pattern is probably one of the most famous sequences we have in all of math. Okay, it's one that's been studied and thought of. It's been used in movies. I've seen it mentioned. I've seen it mentioned in a lot of different places, but it's probably the most famous math sequence we have. And it's known as what they call the Fibonacci sequence. And what that is it's based on how am I getting these numbers? Well, a lot of times when you look at just the differences, the difference between this is 0 and the difference between that is 1 and then 1 and then 2 and 3. So that's not that pattern. If I divide, not going to work. But what happens is that I hope you noticed 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. So I'm adding the previous 2. So in order to write the rule for that, when you want to say previous answers, you use n minus 1. But if I use previous 2, then I have to do n minus 1 plus n minus 2. This means previous answer, and this means two previous ones. Okay, so something the last two together. Okay, so when you want two previous to the one you have, you put minus 2. Okay, now again, for something like this, you need to also remember to tell it where you start. A1 is 1, but if I just give you 1 and it says the two previous, that's not enough. I need the first 2 in this case, because I wanted two previous answers. If I only wanted the one previous answer, then I would have only had to give you 1 and give you n minus 1. But if I want 2, then I got to have n minus 2. Okay, so when you're looking at those rules, it might be just a little bit different than what you're used to, but a lot of times when it's based on the previous 2, that's where you're going to use 2 of them rather than just 1. So let me give you another one like that. 1, 2, 2, 4, 8, 32. So again, looking at the pattern, going from 1 to 2 and then 2 to 2, that's not arithmetic. We're not adding. If I divide, 2 divided by 1 is 2, 2 divided by 2 is 1, that's not geometric. So it's got to be one of those previous things. So let's look at it this way. If I do previous answers, 1 times 2 equals 2. 2 times 2 equals 4. 2 times 4 equals 8. 4 times 8 equals 32. I've got the previous 2, but this time I'm not adding, I'm multiplying them. So my a sub n would be a sub n minus 1 for the previous times a sub n minus 2, the second previous. And because I need 2 of them, you got to tell the person 2 terms. Okay? So on this section today, what you're going to do is you're going to write recursive rules and you're going to find the first 6 terms. So they're going to give you a pattern and you have to go from it. If it's arithmetic or geometric, you use those formulas. If it's a different type, then look at previous 2 or previous 1. Maybe it does something different. Maybe it squares it. You know, that's something you also got to look at or think about. So on the first page or first part, you're going to do page 447. 3 to 24, multiples of 3, and number 25. Okay, there's that one. See you guys.